Okay, so I think we'll move forward. So now, obviously, as we know, we're studying electricity, yes? So what is electricity? We've seen it in our homes. It's for, we use it for everything from, lights to our TVs, to our gaming PCs, to our PS4s, to our phones, everything. We want to charge our phone. We use electricity. It is a fundamental energy and a fundamental aspect of society. As it says here, electricity is an important place in modern society. It is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals, industries, so on. But what is electricity? That's what we're going to learn in this chapter. How does it flow? What are the factors that affect electricity? And how fast, how slow does it flow? What different values does it depend on? So first of all, we're going to be discussing electric current and circuit. What is an electric current? I'm pretty sure a lot of you have probably heard, as we say, like if someone gets shocked, especially in Hindi, we say usko current lag gaya. Like we say that he's been shocked with an electric current. But what is this electric current? So we are, as it says here, we are familiar with air and water current, which means the flow of air and the flow of water. So using that same analogy, electric current is the flow of electricity. Now, where is electricity derived from? Electricity, the word is derived from electron, because electricity, simply put, is the flow of electrons. The reason electricity flows so well is because the delocalized electrons is what we call them. So essentially, if you'll allow me to annotate here, delocalized electrons are those electrons. So for example, if this is like a metal bar, yes, and there's atoms in it, let's say, for example. Between these atoms, there are some free electrons which are not bound by these atoms. Bound means they're not attracted to these atoms and they can roam freely in this. So when electricity passes, Seth is here. Okay, when electricity passes, these electrons, they conduct electricity. Since they're able to move, they conduct electricity and move along the line of electricity, and that is how electricity is conducted. So simply put, electricity is the flow of electric charges, which I think if we read here, it'll be given here. Electric current is expressed as the amount of charge flowing through a particular time, the charge flowing through a particular area in unit time. So if we have, for example, a wire, it has to be of a certain thickness, yes? If it is of a certain thickness, the amount of electricity flowing through this wire in, let's say, 1 second or 2 seconds or whatever time frame you give, that is known as electric current. In other words, it is the rate of flow of electric charges. We know rate is always, whenever you hear rate, you should always divide by T, because rate means anything, the rate of anything is that anything happening per unit time. So rate means anything per unit time. So rate of flow of charges is the flow of charges per unit time, in unit time, as it says here. Also, if any of you don't understand anything, please do not hesitate to let me know. If there's anything, even the smallest of doubts that you have, then we should clear it, because if you were to study this chapter, there should be absolutely no doubt in your mind when you're moving forward. Because if there is, then the later concepts in this chapter, they build on the concepts that we're learning now in the beginning of the chapter. So if your foundation is not strong, then the later concepts will not come to you. And even for example, in grade 12, like I'm studying electricity in grade 12, this is related there. So you need to know that, you need to be, well versed in this chapter. So if there's anything that you don't understand, let me know and I will explain it to you. Also, if you have a problem, maybe you don't understand my accent or you don't understand me that well in English, you can also ask me. I can explain it in Hindi as well. So my computer is glitching out. 1 second. Right, okay. So now that we know what an electric current is, we've also heard of electric circuits. Electric circuits are essentially what we can define as the path through which an electric current flows. So a continuous and closed path of an electric current is called an electric circuit. Most of us, I don't know if you guys, maybe if you're interested in, making stuff like, for example, robots or something like that, or even just in general, when we switch off a light, what do we do when we actually switch off a light? The reason it's the electric circuit is called a closed path is because electric current only flows when it's a closed path. A closed path means that there's no breaks in the, for example, if this is an electric circuit, this is a break. Electrons will not flow here because there's no connection between these two. However, if I connect it, then it will flow. So essentially, a closed path basically means that there are no breaks in the path, which means that there's no open spaces. So current only flows when there is contact between every surface. So when you join two metal wires, that's why current flows, because when you join two metal wires, electrons from here can move to electrons from here. Saif, by the way, we'll be taking this a little bit slowly because there are some new 11th or new 10th graders as well. So I'll be teaching this at a moderate pace. For those of you who are, just waiting to write your boards, we will be taking this slightly slow. So anyway, electric circuits are a closed path for current to flow. So how do we stop current flowing? That's what happens when we turn the light off. When we turn the light off, the switch, for example, if this is a switch in an electric circuit, let's say this is a switch. Yes. When we turn the light off, sorry, is there anyone that wants to say anything? I heard someone. Okay, never mind. We'll move on. So when we turn a switch off, we break the electric circuit, which means that when the switch is flipped to off, then the contact between the two wires is broken and there's air. Now, this is somewhat of, I guess you could say, a little bit of an extra knowledge. Air, as we know, is a very, very bad conductor of electricity. This is because, again, there's not many what we can call there's not many electrons, free electrons, that allow the conduction of electricity in air. So when we break a circuit, obviously there's a gap of air between the two, you can say, wires or two contact points. Therefore, electrons are not able to pass from one contact point to the other. There's no passage of electrons, therefore there is no conduction. Therefore, it is said here, like I said, it is a continuous and closed path of an electric current, which is called an electric circuit. Now, what is electric current in mathematical terms? What is the formula for electric current? Well, we already saw that electric current is defined as the amount of charge flowing through a particular area in a certain time, say 1 second or 2 seconds or whatever time interval you take. The amount of electric charge flowing through that place or through that unit area is called electric current. In other words, it is rate of flow of electric charges. Like I said, in circuits using metallic wires, electrons constitute the flow of charges. However, when electricity was first discovered, electrons were not known at that time. We did not know that electrons existed. And because of this, the conventional, we can say, direction of electric current is taken from the positive terminal of a dipole to the negative terminal. So you must have seen, when you get those AA batteries, excuse my drawing, please. You have positive and negative, and you have positive and negative, and then you have, you put one on one side and you flip the other battery over. So conventionally, when this I have so many people joining, so I'm trying to admit everyone while also trying to take the class. Anyway, so when there's a battery and you connect it into an electric circuit, say this is the battery. So the electrons or the electric current in that circuit will always flow from positive to negative. So what I mean by that is when you connect the battery, it will flow in this manner, from positive to negative. This will always be the direction of electric current. In any electric circuit, it will always flow from positive to negative. And the reason for that is given here, because as we know, when electricity was discovered, there was no concept of electrons. So even though the flow of electrons constitutes electric current, due to there being no discovery of electrons, the conventional we can say direction of electric current was taken from positive to negative, even though the actual we can say the actual direction of electron flow is from negative to positive. So just remember what we say, the flow of electric current will always be opposite to electrons, which is from positive to negative. Always, there's no exception for this. Any circuit diagram, anything that you draw will always be from positive to negative. So moving on, we already saw the, what do we call it? We can say the word definition of electric current, but what is it in mathematical terms? If you were given, for example, the amount of charge and the amount of, or the time period, how would you actually calculate the electric current flowing through a place? So here it is. This is, sorry, does anyone have a doubt? Okay, no, if you have a doubt, you can just you can speak up. I have no problems with that. But I would say if you don't have a doubt, for lest the class get disrupted, I would say everyone please keep your mics mute. So we saw that electric current, I'm rehashing this again, this is the word definition. We saw that the electric current is we can say the amount of charge flowing through unit area or flowing through area in unit time. Yes, in certain interval of time. So what does that mean? That means charge per time. So in electricity, we always denote charge by Q. So, and we obviously, you must have studied in 9th grade, 8th grade, anything. T is always denoted by small t. So charge by time becomes Q by T. And this is equal to I. Electric current is denoted by I in electricity. And so this is the first and one of the basic, we can say, formulas of electric current. How do we calculate electric current? Electric current I is equal to charge Q upon time T. Now, say, for example, if you're given 20 coulombs of charge, we'll come to the SI units of these different quantities later. So just when I say coulomb, for example, the SI unit of, in fact, you know what, let me discuss this. So Q, as we know, is charge, and the SI unit of charge is coulomb, C. It's denoted by capital C, big C. Yes, Aditya. Go ahead. You can ask me the question. You raise your hand. You can type it in chat, or you can speak out. I have no problems with that. Okay. I don't see him asking any doubts, so I'm just gonna say, like, if you guys have doubts, I will wait for a little while, but if you guys are not responding, then I'll have to move on because we can't wait forever. So Aditya, please, if you have your doubt, you can leave it in chat. I'll look at it later because you're not answering right now. However, okay, so moving on. So we have Coulomb, as we know. So Coulomb is the SI unit of charge. And approximately there are, since we know that electric current, constitutes of, charge, or sorry, electric current is constituted of electrons, then what we can say is the charge in 1 coulomb is approximately equal to the charge of 6 times 10 to the power 18 electrons. What does this mean? 6 times, first of all, if we just, discuss this, 6 times 10 to the power 18 is a very, very big number. It's 6 and then 18 zeros after that. It'll be in like trillions, quadrillions. So the amount of charge that 6 times 10 to the power 18, which means like 6 times 10 to the power 18, how much would that, like, I say again, like it's like quadrillions, in more than quadrillions, 18 zeros. So the amount of charge, total charge in that many electrons constitutes 1 coulomb. So we can see that 1 coulomb, especially on a microscopic level, is very, very, very large, especially because the charge on 1 electron, as given here, is 1.6 times 10 to the power minus 19 coulomb, which means that 1 electron has charge of 1.6 times 10 to the power minus 19. What does this mean? This means this is 16 and then 18 decimal places in this direction. 18 decimal places. It'll be 0.00000 18 times and then 16 coulomb. So we can see that coulomb is a very, very large unit of energy. And there's also a relation between these three things. So we know that 1 coulomb is equal to 6 times 10 to the power 18. 6 times 10 to the power 18, we can say the charge in 6 times 10 to the power 10 to the power 18 electrons. So there's a formula here. It's equal to Q is equal to NE. So Q here is charge, E is charge on electron, and N is number of electrons. This is also an important formula, which is actually not mentioned in NCERT for some reason. And this is actually how we derived the number of electrons. If we are given the charge as 1 coulomb, and we are given the charge on each electron as 1.6 times 10 to the power minus 19, minus 19 coulombs, and we have to find out the number of electrons that constitute 1 coulomb, then we just, we take this down and we get 1 divided by 1.6 times 10 to the power minus 19. And this value right here will give us 6 times 10 to the power 18. That's how we got the amount of electrons that constitute 1 coulomb of charge. Similarly, if we are given the number of electrons and we want to find the charge on each electron, we have 1 divided by 6 times 10 to the power 18, and we will get 1.6 times 10 to the power minus 19. So this relation Q is equal to NE is very important, especially for finding these values. If you forget them, if you remember even 2 of them, then you can find the third. Now moving on, we saw that I is equal to Q by T. So that means current is equal to charge by time. And so we know that the SI unit of current is coulomb. And we know obviously the SI unit of time is seconds. So remember this is very important, seconds. So when many times in questions, especially in boards and stuff, many times they'll give you the time in hours or minutes or something like that. Before solving the question, you always have to convert it to seconds, because seconds is the SI unit of time. SI means the international standard. It's actually in French, the Standard International, but we call it international standard. So this is the value, standard value accepted all over the world. That's why even in NCERT, when we solve things, we use SI unit, because that's what all the scientists around the world usually use. And it is, it's regulated by a certain body of, it's a French body, and it's like International Council for regulating weights and measures and etc. So always, when you see time, it should always be in seconds. Always convert to seconds. Coulombs or charge always convert to coulombs, in the sense sometimes maybe it'll give it to you in kilocoulombs, which I don't think should be, I mean, they probably won't, but if they do, you have to multiply by 1,000, because 1 kilocoulomb is equal to 1,000 coulombs. And its SI unit is denoted by A. This is ampere, A-M-P-E-R-E. And it is named after Andre Marie Ampere, because he discovered this sort of relation. So Andre Marie Ampere was a French scientist, and the SI unit of electric current, ampere, A, is named after him. And we can see that since we, it's equal to, current is equal to 1 coulomb per 1 second. So 1 ampere is equal to 1 coulomb per 1 second. So that's the definition of ampere as given here. So 1 ampere is always equal to 1 coulomb per 1 second, because, I mean, if we just put the SI units of each quantity in I is equal to Q by T, so we know I is A, so 1A is equal to 1C by 1S. So again, to recap, the electric current of I, which is, or the SI unit of electric current, or I, is ampere. The SI unit of charge Q is coulomb. And the SI unit of time T is second. You can also write it as SEC or S. Either one is correct. Now, moving on from that, we also have certain quantities for amperes. We have milliamperes and microamperes. Sorry, 1 second. So for microamperes, we denote it by this U-like symbol. This is the Greek letter mu. So mu A, it's read as mu A, and obviously M is milliamperes, which is kind of obvious. We have millimeters, similar to that, milliamperes. So the values of these, 1 milliampere is equal to 10 to the power minus 3 amperes, which means it's 1 divided by 1,000 amperes. So if you're given, for example, you're given 30 milliamperes, this will be equal to 30 divided by 1,000 amperes. I believe the meeting is going to end in approximately 10 minutes, so I request everyone to join again, whoever would like to attend. And I request that you guys join immediately, because we don't have that much time. So anyway, so we have milliamperes. Milliamperes is equal to 10 to the power minus 3 amperes. And microamperes is equal to 10 to the power minus 6 amperes. So especially in boards, these are the quantities that they will try to trick you on. It's not really a trick, but they sometimes will give you current in milliamperes or microamperes, which means every time you solve the problem, you have to, if you're given milliamperes, you have to multiply by 10 to the power minus 3. And if you're given microamperes, you have to multiply by 10 to the power minus 6, because otherwise your answer will not be in the standard unit. So always, 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 you have to bring all of these quantities into their standard unit, which is coulomb, second, and ampere. So, okay, that was, I guess, the gist of electric current. You guys can, read through it. I do recommend, after you do the lesson, whenever you have time, please do read through the book, the NCERT book. I know sometimes the language is hard to understand, but in boards, NCERT is paramount, especially for 10th grade and anything. NCERT is the first book that they look at. So first complete NCERT, then move on to other books. Yes, Aditya, you raise your hand again. Please hold forth. Okay, well, he's not responding. You can write it in chat. Like I said, you can leave your messages in chat if you have any doubts. However, if you don't respond in a few minutes, I will move on. Now, so we've seen about, electric current and things like that. So again, as it says here, small quantities of current are expressed in milliamperes, which is 1 milliampere is equal to 10 to the power minus 3, or microamperes here again, 10 to the power minus 6. Now, an instrument, okay, this is also very important. This is called an ammeter. So this is an instrument that we usually use in this is, you know, circuit diagrams. Later we'll get to circuit diagrams. Circuit diagrams is that exactly like a, I guess you can say it's a schematic representation of an electric circuit. So an instrument called the ammeter measures electric current in a circuit. So this is a we can say instrument that measures the amount of electric current flowing through the circuit at a time. So, you know, when we see I guess you could say, if you look at your battery for like, you know, on your charger for your laptop, for example, and it'll be like, you know, 1.5 amps or something like that. That means that much current will be flowing through the charger at a certain time. And to measure that, we use an ammeter. So an ammeter is an instrument that measures the electric current in a circuit. It is always connected in series. Now, in series means it is connected like this. What we can say, it is connected in a row or in between two wires. So like the wires will pass through the ammeter and the current will flow through it. Obviously, if you want to measure the current, you need the current to flow through the device, therefore measuring it. So when they say in series, it means that it is connected, we can say between inside the electric circuit. And we'll get to a voltmeter later, which is not connected inside the circuit and is actually connected outside in parallel. Now, I want you guys to try this problem, exercise 12.1. I'll give you guys like 10 minutes. This is actually a quite easy of a problem. You guys try this and tell me what answer you get. You can type it in chat or you can tell me on the mic. Okay, can you guys hear me now? Hello? Okay. I'm not sure why I wasn't audible. Anyway, it is indeed 300 coulombs, and I don't know why I wasn't audible. Maybe a glitch in the system. I was basically I was just explaining how we got that. So we have 0.5 amps, and we have 10 minutes, which is 600 seconds, and then we know I is equal to Q by T. So Q is equal to IT. And so we just put values of I and T, so 0.5 into 600. And to make it easier for ourselves, although this is, again, a very easy calculation, it shouldn't take you too much time, but to make it even easier, 0.5 is 1 by 2 into 600, which is equal to 300. Now, these questions here, these in-text questions, I'd like to hear. Okay, so I'll ask you maybe one, and then I'll explain the other two. So what does electric circuit mean? This is a very basic definition. I want to hear from you guys. What did you guys understand from electric circuit? Yes, continuous path and closed path of an electric current is correct, which is circuits. For your doubts, Sarfaraz, yes, we always have to convert minutes to seconds unless stated otherwise in the question. So if we are given that, in the question it says give the answer in minutes, then you don't have to convert it. But always, if it is not given in the question, you will always have to convert time from minutes to seconds. It's because, again, like I said, it is the SI unit. You always have to convert to seconds. Same way you always have to convert charge to coulombs, and you always have to convert